when you look at these coordinates, one of the coordinates, x or y, was the sine value, and the other one was the cosine value. Do you remember, was cosine x or was cosine y? Cosine was the x value. So this is going to give us a brand new formula. Notice if I put cosine in for x, it becomes cosine squared of theta. And if I put sine in for y, it becomes sine squared of theta is equal to 1. And most notably, this is written as sine squared first. Sine squared of theta plus cosine squared of theta is equal to 1. This is the most important formula next to the Pythagorean theorem in all of trigonometry. That is something you can never forget. Sine squared of theta plus cosine squared of theta is equal to what? 1. You can't forget this. Just like you know, what is the capital of the United States? Washington, D.C. What is the capital of Minnesota? St. Paul. What is the capital of Wisconsin? Madison. We're going to try another one here. Okay? Ready, Liv?
Yep.
Give us a good one.
Gotcha.
I'm not giving them out.
Okay. Look at me. Do you know the capital of Alaska?
Oh, I know.
Nope.
Try again. Okay. Ready?
Yep.
Do you know the capital of Alaska?
Yep. That's a good one. Wait, what?
Do you know the capital of Alaska?
Juneau?
Juneau, very good, yeah.
I'm sorry.
Do you know the capital of Alaska?
Juneau.
See, I wasn't asking you earlier, I was just making a statement. Juneau, the capital of Alaska. You know, Juneau is the capital of Alaska. Yeah, very good. You like that one?
No.
Very good. Okay, I liked it. That was fun. It all gave us a little bit of joy. If it makes you any better, somebody first hour we asked the capital of the United States, and they said America. So, and they put their head down. They said, "I'm having a bad day." So,
They said America? Can you name drop?
No, I will not. Okay, so on your sheet, look at this. Number 5 says sine squared plus cosine squared is 1. You're going to have to use that today. And we can come up with all sorts of other equations from this. Watch what will happen here, folks. You need to focus on this. Suppose I would subtract a sine squared from both sides. Suppose I would subtract a sine squared over. Does everybody agree the new formula would be cosine squared of theta is equal to 1 minus sine squared?
Yeah.
Or I could subtract the cosine squared to the other side instead, and I would get sine squared of theta is equal to 1 minus cosine squared, wouldn't I? Those are written on your sheet as well. It's very important that you find these. Look at your sheet, number 5. So everybody see 5 says sine squared plus cosine squared is 1? And then move to the right. Do you notice how it says cosine squared is 1 minus sine squared and sine squared is 1 minus cosine squared? That's where you're going to locate those. We're going to come up with a couple more, number 6 and number 7. You're almost done with this part. You're doing a good job. I'm going to write it down again. Sine squared of theta plus cosine squared of theta is equal to 1. And instead of subtracting something from both sides, I'm going to divide through by something. And I'm going to divide through by cosine squared. Yep, this is complex.
It was easy on Friday. Can we keep it like that?
Fortunately, you're really smart, so you're going to get it. What is sine squared divided by cosine squared? Tangent squared. What is cosine squared divided by cosine squared? 1. 1 over cosine is the same as secant squared. Look at that formula. Do you see that on your sheet? Which number is that?
6.
Number 6. And then if you move to the right, you're going to see some other ones. What do you see as you move to the right? You see 1 is equal to secant squared minus tangent squared, and you see tangent squared is equal to secant squared minus 1. See both of those? Okay, our last one. One more formula. I'm going to go ahead and write down sine squared plus cosine squared is equal to 1. And instead of dividing by cosine squared, anybody going to guess what I'm going to divide by? I'm going to divide by sine squared. What is sine squared over sine squared? 1. What's cosine squared over sine squared? Cotangent squared. And what's 1 over sine? Cosecant squared of theta. Do you see that formula on your sheet? Which one is that? Number 7. Very good. So we want to use those, folks. We want to use them today as we work through 7 of these examples, 7 of them. Actually 6. We're going to get rid of number 5, cross number 5 out. You will not be ready to do your assignment today. You'll be ready to do your assignment tomorrow. This is a 2-day lesson. Remember that what we did on Friday is we rewrote this stuff in terms of sine and cosine. What you want to do today is you want to make a substitution. Anytime you see a 1 and a squared, you could probably put something in its place. Look at your sheet. Instead of 1 minus cosine squared, what could I put in its place? Sine squared.
Wait, where are you finding this?
Well, look at your sheet. If you look at this piece right here, okay, notice that because you have a 1 and a cosine squared, you're drawn to number 5, right? And if you follow it to the right, it says cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. You see those?
Yeah.
So we're choosing to use 1 minus cosine squared, the same as sine squared. So this becomes sine squared times cosecant. Now I'm going to do just what I did on Friday. I'm going to write this as sine squared of theta over 1 times, what do I write instead of cosecant? 1 over sine. And what happens? Do both of the signs cancel? Just one of them. So the denominator will cancel 1 in the numerator, and I'm left with sine of theta. I see another squared and another 1. Look at your sheet and talk to the person next to you, okay? What do you think you can plug in for secant squared minus 1? Try to find it. Try to find it. Look at your sheet. What can you substitute in? Squared.
Okay.
Instead of secant squared minus 1, I'm going to write tangent squared. So this becomes cosine squared times tangent squared. Everybody okay with the tangent squared?
Yeah.
I got to rewrite that. I've got cosine squared of theta over 1 times, instead of tangent squared, I write sine squared of theta over cosine squared. This becomes a problem just like we did on Friday. What happens? Cosine squareds cancel, and I'm left with sine squared of theta. Anytime you see a squared and a 1, think of something you can plug in. We just did it. What can you plug in for secant squared minus 1? Got tangent squared divided by sine squared. Notice this one is dividing. We could write that as sine squared of theta over cosine squared of theta. All over sine squared of theta over 1. What do we do at this point? Multiply by the reciprocal. Hannah ate her Wheaties today. Way to go. And notice that the sine squareds cancel, and I get 1 over cosine squared. Is that my answer? No, because what's 1 over cosine? This becomes secant squared of theta. What do you think?
Not horrid.
The next one, you don't have a 1, do you? So I'm going to try to create a 1. Sometimes we lose people in this process, but I'm going to rewrite this. Instead of looking like that, I'm going to rewrite it as x squared minus x squared y squared. Okay? Now, you'll see why I rewrote it like that in a second. I'm trying to help you out. Okay? If I were to factor this, what is the common factor that both of these terms have? They both have an x squared. If I factor out an x squared, what's left? A 1 minus the y squared. Does everybody see how I end up with a 1? X squared times 1 is x squared, and x squared times y squared is x squared y squared. So, now let's go back to the trig problem. What is the common factor I could take out of both of those? I could take out a tangent squared. And what are you going to be left with? Good, 1 minus sine squared. Hey, now I've got a 1 and a squared. What is 1 minus sine squared? Ooh, look at your sheet. What's 1 minus sine squared? Cosine squared. So I have tangent squared times cosine squared. So I'm going to rewrite tangent squared as sine squared over cosine squared times cosine squared over 1. What happens when I multiply those? Cosine squareds go away, leaving you with sine squared of theta. Only 2 problems left to practice right now. I want you to try number 6 on your own, and here's the hint. You're going to start by factoring out a cosine squared. Start by factoring out a cosine squared, see what you could come up with. So, factor out a cosine squared. The 1 plus, yeah. Go ahead. And then, what is 1 plus tangent squared?
Oh,
Okay, I take out the cosine squared, and I'm left with 1 plus tangent squared. There needs to be a light bulb that goes off in your brain and says, hey, if I get a 1 and a squared, I could probably substitute something in. What is 1 plus tangent squared? Secant squared, and that is something that's right on your sheet. That's number 6, isn't it? I could rewrite secant squared as, looks like they're both going to cancel, which gives me 1.
Is this our last unit test?
It's your last test. Tangent squared.
Ever?
For 3rd quarter, this will be your last trig test. Then we move on to statistics. Statistics is easy.
Scary. What's it about?
Statistics.
Of what?
Statistically, it's about.
Well, for example, can I show right after you do this one?
Yeah.
Okay. So I have some options here. I can plug in sine squared of theta over cosine squared of theta for tangent. Or I could plug in secant squared of theta minus 1. Or I could take the bottom, and secant squared minus 1 is the same as tangent squared. Some of these are good options. Some of them are bad options. Which one do you think is a bad option? The first one, if I were to rewrite this top as sine squared over cosine squared, that doesn't really help me, does it? But if I plug in this for the top, or if I plug in this for the bottom, does everybody see that you're going to get the same thing on the top and the same thing on the bottom?
Yes.
Yeah. So in other words, I could take and write this as tangent squared, just leave the top alone, and I could rewrite the bottom as tangent squared. So I want you to understand that sometimes you're given choices in how you want to go through it. It's up to you to pick one. And here, 2 of them were correct options. This one was not a correct option. That's just something you have to see. You get 1. I would not start your assignment today. I would wait till tomorrow as we do a little bit more work, okay? Good job.